This is our another video for this chapter, right? So this is second part. So here today we'll be discussing about intersecting lines, parallel lines, its properties of lines, okay, and how to draw a line segment and all. So let us directly move on to this part. So the first thing that we will be discussing today is intersecting lines. So what are intersecting lines? And we have two types of lines for now. Here it's intersecting lines and parallel lines. Okay, so the definition is two lines that have a common point are called intersecting lines. So how does a intersecting line looks like? That means there are two lines, okay, there are two lines, but they have a common point. That means they are called intersecting lines. So how does it look like? Let us see. So suppose I have one line segment as this, or lines, we can just take a line because it can just be taken as this. Suppose this line be E or L, anything, okay, you can give you any name for this. Suppose there is one line called A, okay, and there is another line called B which is crossing this line. Okay, let me do it with different colors. This, suppose this be B. Here we see that A is A and B, they are crossing each other and they have a common point here, and the common point is this part, right? This part is the common, the red dot is the common point here, right? So this part, this dot be suppose X, capital X. That means these two lines are crossing each other no matter what, but they have only one common point. So that's why they are called intersecting lines. Okay, so it is not that it has to be this way. Sometimes it may happen like this also. Suppose I have one line segment coming to this side, okay, it's not ending, okay, it's just coming like this, okay, one line segment. Another line segment is still there, even though it is not meeting, but it can also extend up to infinity because this is a line, it's not a line segment. See this line, because there are arrows on both the sides. Suppose this line be A, B, P, Q. So A, B and P, Q, there are two lines. A, B is one line, P, Q is another line. They are what? They are intersecting because ultimately they gonna cross each other at this point. Suppose this point be P. So they are crossing each other at point P, right? So that's why they are called intersecting line. Okay, whereas parallel lines are those lines where they do not cross each other. Instead, they never cross each other, right? So how does it look like? So two lines in the same plane which do not have any common point, no matter how far they are extended, are called parallel lines. So even if you keep on extending, it will not meet at any point. Okay, suppose I have one line, okay, this is line, let me write line, suppose P, Q, okay, or X, Y, or you can just simply give the name as L also. Okay, you can just give the name as L, line L. Okay, and we have another line, that is A, B. Okay, let be A, B or M, line M, line L. Okay, so even if you extend this one, say the extending part with black dots, even if you keep on extending towards infinity, it will never meet. Okay, this type of line they are called parallel lines, and the distance between them will be equal throughout. Okay, suppose if it is 10 meter, this will also be 10 meter, this will also be 10 meter throughout, and it's never gonna be 10, 9, 8, 7, 6, no, it will be 10 meter throughout the process. Okay, such lines, they are called parallel lines. And the simple example that you can take in parallel lines is railway track. You have seen the railway track, right? It is like this. Railway track, road, okay, parallel road, you can just see. Okay, so this is called a railway in parallel lines. And one thing I forgot to mention in this intersecting part is that this point, okay, where the two lines intersect, they are called a point of, it is called point of intersection. It is understood, okay, because they are intersecting each other, they are crossing each other at one point. So this point is called point of intersection. You have to remember this. All right. So next we have another part, that is incidence properties. So what is meant by incident properties is like a point and line can have certain properties, right? Point and line can have certain properties which are universally accepted. Okay, which is universally accepted means which is universally accepted in a sense like the concept is same throughout the globe. Okay, which you cannot change, which is accepted universally or globally. So those are fundamental. Okay, so those properties, they are called incidence properties, and we have basically three properties for now. So let us discuss one by one. So an unlimited property 1, it says that an unlimited numbers of line can be drawn through a given point on a plane. Suppose for this, let us draw an unlimited numbers of line can be drawn through a given point on a plane. That means if I have one point, if I mark one point, if I mark one point on a plane, this seat is my plane, this screen is my plane, so I'm marking one point or a dot on this plane, right? So how many lines can be drawn through this given point? What do you think? So let me draw. I have drawn one line. This is one line. This is P A. Okay, but I cannot draw the same line with one other point, because since the dot is just simple dot, just I'm for our time being I'm just making it bigger dot, right? But it is very small. Again, I cannot make another line on top of this and I can say it's a B. No, you cannot. You have to slightly change. So another line I can make is B. Again C. If I take this, D, E. So it keeps on going. So what do you think? How many lines can be drawn? So it is unlimited. So you can draw unlimited numbers of line through a given point. So the property 1 says that. Okay, and or it can also be said like only one line can be drawn through a given point in a particular direction. Direction is there. So if you want to draw A, right, we have drawn this way, there was one dot and we made it this way. So only A can be drawn here. Other than A, B, C, D cannot be drawn over this point in the same direction. Same direction cannot be drawn because there is already one line and you cannot draw another line on top of this and name it as B. So in a particular direction you can draw just one line through one point. All right, remember these things. So next property is one and only one line passes through two distinct points in a plane. Okay, it says that if you have 2 points, if you have 2 points on a plane, so how many lines can be passed through this point? Let us see. Suppose if I draw one line here, if I elongate that, again if I elongate it, Okay, this line is there. These are all lines. Again, if I draw another line, if I draw many lines like this, we never know how many lines are there, but still, even if you draw these lines this way, and ultimately so there are many lines, okay, but out of this you can easily find that this line there's supposed to be A, B, or you can just say line P. This is the line which can only pass through 2 points. So how many lines can be drawn through passing through 2 point distinct point? That is only one line. Okay, so only one line can be passed through this point. Suppose this be O, X and Y. This points be X and this point be Y. So if you are confused with this, you can just take like this. Just mark 2 dots and just draw one line. So it is clearly understood that this point, this line is passing through 2 distinct point, right? So what do you think? Only one line can be passed through this 2 point distinct point, because they are separated, right? So only one line can be drawn. Okay, similarly that can be understood as property 2, right? So next we have property 3. So to understand with property 3, I have taken this image from the book itself. So property 3 is actually already discussed in this parallel lines and intersecting lines, but it is advancement of those concept only. So two different lines in a plane are either parallel or they intersect exactly at one point. Means that suppose there are two lines, okay, here we have L and M. Okay, let me see, there we have L and M. There are two lines, okay, these are two lines, but these two lines can have two roles. Either they intersect each other or they will be parallel to each other. So that is the concept. Okay, so here in case 1, L and M intersect at A. You can easily see here L is one line, another is M. They are intersecting each other at A. So A is the point of intersection for now. But in case B, line L and M intersect at A later on, but when only line L is extended. Means that if you see here, suppose I have AM is already there. Sorry, this line M is already there. Suppose there is line L coming towards this line L. So ultimately after some time it will come and meet at A. So it means that line and M also intersect, line L and M intersect at A, okay, when L is extended. So if it is extended, then it will meet at A. It is saying that. Okay, similarly for C, line L and M intersect at A when they both are extended. When they are both extended, like C, suppose I have another line as L. Okay, sorry, the previous line is L and another line as M. So although they are not meeting for now, but after some time, if they are extended like this, then they are going to meet at exactly one point. That point is A here. Okay, it is saying that. So these are all intersecting lines, this. But for now, for the equation in case D, it is saying that line L and M do not intersect even though they are extended. So even though they are extended on both the directions, see, if it is coming to this direction, this is going to that direction, towards right, even here and here, both they are extending towards infinity, right? But they are not meeting at all. So they are called parallel lines. So this is the property 3. So next we have collinearity of points. So what is meant by collinearity? three or more points lying on the same line are called collinear points. Suppose we have dots, many dots, okay, okay. Suppose here, if you want to connect, if you want to make a straight line, if you want to connect it, I can easily see that this line can be connected with all dots. So let me mark it, this, and this. Suppose this be A, B, C, D. So this is a line L. So line L has 4 points. Okay, line has 4 points. That means that 4 points lie on this same line. That means they are collinear because 3 or more points lying on the same line. Okay, but if I have suppose 3 points like this, but only 2 points can lie on the same line, suppose this is P, that means they are not collinear because they are having only 2 points. If they are having 2 points, that means they are not collinear, they are line segment only, they are not collinear. Okay, but here in this case the line L has 4 points, distinct point, that is A, B, C, D. It can have more than 4 as well, it can have n number of points. Okay, but it should have more than 3. So if there are 3 or more points which is lying on the same line, they are called collinear points. Okay, so concurrency of lines. So what is meant by concurrency is that if we have one point, okay, so if you draw one line here, and if you draw another line, okay, and another line like this, okay, if you keep on drawing, okay, if you keep on drawing, and if all the line they passes through this particular point, they are called concurrency of lines. Okay, so let me draw. This is L, M, N, O, P because it's already L. L, M, N, O, P. So 3 or more lines passing through the same point, they are called concurrent lines. So there are many lines, right? But they are, if they are passing through just one point, okay, common point, they are called concurrency or concurrent lines. Okay, it is very simple. It is the application of first property, this concurrency of line. Okay, so next we have measurement and construction of line segment. So how do you measure and construct a line segment? This is an important topic. Okay, so why do we need to measure and how do we construct a line segment? Is that a line segment is measured by comparing it with standard segments. Okay, it is compared with standard segments. Okay, so it is referred to as unit segment as given in book. Why unit segment? Because every segment is a unit. Okay, small units. Okay, so number of times a unit segment is contained in the given line segment is called its measure or length. Means that a number of times a unit segment is contained. Suppose in scale, if you use ruler, or if you say it's scale, right, but the proper term is ruler. If you use the ruler, if you see that there are many segments to it, like this, we have many segments in ruler, right? Okay, so number of times a unit segment is contained. So if I want to measure from this to this part, I go through every segment 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. We write 17 units, right? Okay, so this units, they are called measure of the length, measure or the length. This is called a measure. Okay, what is the length? We simply say what is the length of the pencil. What we say, what is the length of the ruler? What is we say like length of book, length of stick, right? We use that term. So basic unit of length that in the international system of unit is meter. So we use meter, but meter cannot be used in smaller cases, like if you want to measure a length of pencil. If you want to measure length of, you cannot use meter. okay, we use centimeter. But centimeter can be used for higher dimensions, not higher dimension, higher lengths, right? If you want to measure a length of cloth required to make a dress, we use the term concept of meter. Okay, so yeah, so 1 meter, okay, 1 meter contains 100 equal parts. Okay, 100 equal part, okay, and this 100 equal part is centimeter. In our case we write cm, okay, in short form, but it is centimeter that we use it every day, okay, mostly. And 1 centimeter has 10 equal parts, that is 10 equal part is millimeter, okay. And we will go on to this a bit later about this concept while drawing a or constructing a line segment. All right, so yeah, and basically the ruler that we use in everyday life, it has centimeter and inches, okay, but we don't use inches for now, we just use centimeter, and millimeter is already there because there is centimeter, so it is included there itself, right? So the ruler is generally 15 centimeter length with inch mark on one edge, okay. So if I have to show you ruler, it's like this, see, okay. So this is centimeter, these are all centimeter, and these are all inches, this part, okay. So here we see that there are small fragments, 1 2 3 4 5, sorry, 0, this is 0, okay, this is 0, 1 2 3 4, this becomes 5 6 7 8 9 10. So there are 10 small segments which makes 1 centimeter, okay. This is a ruler. So this marks on the ruler are called this mark, okay. There are small mark fragments, right? So they are called graduation or calibration, okay. So these are also sometimes called graduated ruler also. So let us see. So how do we measure an object? Let us see here. So measuring object, so always you should start from 0, you should not start from 1. What I see is like there is a little bit of confusion among the student that you start from 1. You should not start from 1, because if you have tiny object if you start measuring from 1, that becomes 1. Suppose this is 1 1 point something. So if it is very tiny, how can it be 1? Okay, it should be lesser than 1. So you should always start measuring from 0, because that is the initiating point, this is starting point, okay. Starting point, that is 0. So where does it ends? See here, it ends at 6. Suppose this is, oh, it is inches, it is given inches, right? So it ends at 6. That means my answer is 6 inches. Again, it is starting from 0 and it ends at what? 3. So it should be 3 inches. Again here, if it is given centimeter, if we change this for now, suppose this be centimeter, let us see, it's starting from 0, again it ends at 4, we write 4 centimeter. Again here, start from 0, ends at 5, we write 5 inches. Again it starts from 0 and ends at 2, that we write 2 inches. Drawing a line segment, right? So how do we draw a line segment? For that we use the help of scale, okay, or ruler. So how do we draw? Let us see. Suppose if you have to draw a measure or line segment, a line to a given line segment AB. Suppose AB is given as AB equals to, suppose 4.7 centimeter, okay. Here I take this help of this ruler, okay, I take help of this ruler. Okay, I'll make it 15 centimeter because okay. Okay, so now what I do is like let me write. So I'm making a line segment of 4.7 centimeter, isn't it? So what I do is like I'll take help of this ruler. Okay, so what I do, first I make one dot. First I'll make one dot. I'll make one dot. So now I take the ruler here, I'll place it at 0. So where is 0? It is here, this part. The where my dot lies, it is 0. So I want to make 4.7 centimeter. So before point, these are all bigger segment. So I'll mark in bigger segment all, yeah, bigger division, we can just say biggest division, and this 7 is smallest division because it is behind point, smallest division, right? So 4 biggest division and 7 smallest. So first I'll mark it at 4. Where is my 4? Okay, it's here. 4 bigger, then after that 7 small. So 1 2 4 bigger here, 1 2 3 4 5 6 and 7. So it ends here, right? So now what we do, I'll just draw a straight line and connect these 2 points. Done. So we are done with our construction. So I'll erase this part for now. Okay, so this line is called 4.7 centimeter, or you can name it as AB. So AB line segment 4.7 centimeter. Okay. So if you are not familiar with it, let me do it again. I take another example for this. Okay, this is okay. If the question says like, if you want to construct another line segment, suppose this be xy equals to 9.9 centimeter. Okay, 9.9. You'll take this small fragments only, you'll not take bigger fragments only, because these are inches. You'll just use the portion where it is written mm. So where the mm is written, that is 0 only. Okay, so what I do now, 9.9, right? So what I do is here, okay, so first I'll mark 0 point. Okay, initially you have to mark where there is 0. So now we move on to bigger fragments and smaller fragment. What is the bigger fragment here? 9. Smaller fragment also 9. First we move on to bigger fragments. 1 2 3 4. Here it is 9, right? So you will not mark, but it is understood that bigger fragment is 9. Then after that you will go for 9 segments, smaller fragments. 1 2 3 4 5 6 7 8 9. So lesser than 10, greater than 9. So what I do now, I'll connect these 2 points, and this point label it as x and y. So this is 9.9 centimeter. We see it xy equals to 9.9 centimeter. All right. And sometimes it is also given that instead of 9.9 centimeter, it is also given that 9 centimeter 9 millimeter. So you have to understand that it is 9.9 centimeter. Even in my earlier case, it is given as 4.7 centimeter, right? It is like 4 centimeter and 7 millimeter. You have to understand it yourself. So this completes your chapter. Okay, so this is the basic concept of geometry. So later on we'll be dealing with other aspect of geometry. So for now, you need to go through this video, and assignments will be sent to you as early as possible. It is already prepared, but I cannot send you assignment beforehand, before this video. So I hope you are able to understand. If you are not able to understand, you can ask me, practice it well, okay? And I have given extra questions in the assignment. Kindly do that and submit the assignment to your respective teachers. All right, everyone, take care, stay safe, see you soon.